So for example, if the user stops typing commands on the client, on his server that sends it to the client, now, for example, for a couple of minutes or more, the inspection engine on the client network is going to drop the connection because it sees that the timeout has expired. However, with keep alive messages, the connection is always alive. The second purpose of keep alive message is that any command you send from the server to the client is carried in a packet that's a reply to the keep alive message. For example, if you are tunneling in, for example, FTP, the keep alive message would be something like FTP request. And the command that you send from the server to the client will be coming as a reply to that message. So the keep alive message is used as well as a request for which the reply carries the command from the user to the client. This diagram shows the session establishment and the difference between TCP and UDP. In the TCP section, TCP three-way handshake takes place, and then keep alive messages are sent at periodic basis. However, with the UDP, there is customized initialization and acknowledgement packets that take place between the client and the server, and then keep alive messages are sent at periodic basis as well. Now, let's talk about how commands are being executed on the client. You see in the first example I show you, which is the netcat example, netcat does the following. It attaches the shell process to the TCP stream. So the shell is attached to the TCP stream, and the standard input and standard output of the shell is actually the input and output of the socket, of the network socket itself. However, the way we implement it here with next generation reverse shell is we have the shell process running separately on the client. It's actually forked on the client, and then it pipes its standard input and output to the main process. Now, this enables us to check every command coming from the server or the user to the client. So the client process, the main process, can check this command before it passes the command to the shell process to be executed. Not only that, the other advantage of having a separate process for shell is that we can fork multiple shells at the same time. We can fork multiple processes, and every process has its own shell. So we can have multiple shells at the same time. Something else. When we issue the command from the server to the client checks it if it is an internal command. I'm going to discuss internal command shortly, but before passing any command to the shell process to be executed, we check if this command is internal command, which is different than shell command, so that we can control the behavior of the reverse shell tunnel itself. Okay. Here's the diagram. You can see the main process. It forked a shell process, and then the shell process is piped to the main process, and any command coming to the main process can be diverted to the fork process, and then the result is read back from the fork process. Controlling multiple clients. This is the third implementation feature. Controlling multiple clients happen when the server is listening continuously on the available ports. For example, if our server can tunnel reverse shell within HTTP, SMTP, POP3, the server is always listening on those ports, and then any new client connects to the server is going to inform the user of this new client, and the user can access that client and issue shell commands and have interactive shell. At the same time, while the user is having interactive shell with the client, the server is still listening for more clients, so that you can have multiple clients being controlled at the same time. Now, coming to the internal NGRS commands. In order to maintain these features of flexibility and reliability, etc., we need to have a system of internal commands. For example, you are trying to control a client and you are issuing shell commands. At the same time, where you issue the shell commands, you can issue specific commands called internal NGRS commands, and these commands are not passed to the shell process to be executed. They are checked by the parent process, and then every command has its own behavior or its own performance. So the client performs specific action when it receives one of these commands. Currently, there are 16 internal commands. I'm going to go through them quickly. Set server IP and get server IP. You can change the server IP address or get the current server IP address at the same. You issue this command like issuing any other shell command at the same place. For example, you issue, for example, ls. At the same place, you can issue, for example, set server IP. You give it another IP, and then you have another connection from the client to that IP. Set the protocol and get the protocol. You can set the tunneling protocol on the fly using this command. For example, if you have the tunneling protocol HTTP, you issue set protocol FTP, and then you have an FTP. Get protocol, you get the current tunneling protocol. Set ports and get port also change the port number of the tunneling protocol of the tunneling traffic. Set encoding, get encoding. You can set or switch on, switch off encoding. Create shell, delete shell. You can create multiple shells. For example, when you establish the reverse shell connection at the first time, you have only one shell. With the create shell command, you can create another shell. You issue create shell again, you have a third shell, and so on. And the command set shell can actually switch between the interactive shells. For example, you have now shell number 2, you are accessing shell number 2. With set shell, for example, you can say set shell number 4, and then you are accessing shell number 4, executing command shell number 4. The final command, sleep command, you can, for example, if you are controlling client right now, for example, and then you want to go, for example, for 10 hours and then come back and have your shell, you can just type sleep 10 hours, and then all the traffic is disconnected, no communication between the client and server, and after 10 hours, the connection is reestablished again. Multiple shell spawning, which is another technical feature here. You can see there are multiple shells running simultaneously at the same time. Sorry. Running at the same time, every shell preserves its own current working directory. You can see shell number 1, for example, in the third point. Shell number 1, it maintains the root directory. Shell number 2 /root directory. Shell number 3 /home, etc. So, for example, you go to shell number 3, you issue your command, it goes directly to that directory. You go to shell number 2, you are already on the current working directory of shell number 2, and so on. That's the advantage of having multiple shells at the same time. I'm going to delay the demo at the end so we can. Okay. Now I'm going to speak about the implementation, the technical implementation of every tunneling protocol. We have HTTP, POP3, SMTP, FTP, and NTP. With the HTTP implementation, we utilize the get and post methods. So, for example, every request or every message coming from the client to the server, they use either get or post. Get is used for keep alive message, while post is used to send the result back to the server. Now, how do you send the actual command from the server to the client? you use them using the server, the HTTP response codes, which are 200 OK and 404 not found. So the client sent GET request, and then the server issues 200 OK with the command, and then the client issues POST with the result of the command execution. Here you can see this diagram. First, the client said, get I am ready packet, which is actually keep alive, and then the server responds to this message by sending 200 OK reply with the command enclosed with HTML to give it web taste, and then the results will be posted back using POST method to the server. Okay, now we can see a quick demo here. All right. So, okay. Okay. We are going to see a reverse shell tunneled in HTTP protocol. So this server is actually the server controlled by the user, and that's the client, which is a compromised system behind a firewall. Now, okay. If I issue command get protocol, which is internal command, the tunnel is HTTP. Shell command, another shell command, third shell command, and so on. You see, we are having now reverse shell over HTTP. If you go to the sniffer here, I'm not going to go through all the packets, but you can see it's actually HTTP. All the traffic happens through HTTP protocol, as GET and POST and reply and so on. Okay. Now we move to the FTP-based implementation. There is a difference between FTP implementation and HTTP implementation. To have a standard FTP traffic, we need to send, or a transaction, which is called initial transaction between the client and server, has to happen. And this transaction utilizes the command user pass, print working directory, and so on, and passive mode. There is something I would like to mention here, that in FTP implementation, we have the data channel and the control channel. The data channel always happens using the passive mode, because you need the client to connect back to the server, not the active mode. After the initial transaction happens, the client sends the FTP command called list, which actually instructs the server to list files on that directory. The server replies with file list, and the file list includes the commands from the user. So the commands, the shell commands issued by the user are transferred as file names to the client. The client extracts the commands, execute the commands, and get the results. The results are sent back as files. So the client issues the command, store the command name, and then on the data channel, it sends the command, the execution result. You can see here in this diagram, from